Okay, today we're going to look at adding and subtracting fractions. The first one will be a subtraction problem, 7/9 minus 5/12. Now, the reason we learned all that prime factorization earlier was so that you could understand how to find common denominators and all that other stuff that's important. So over here, the first thing you have to do, because the denominators on these two are not the same, we have to look at, well, where do we have to go to meet the same requirement by increasing each fraction's bottom and top in order to do that. So it's a process of looking at the 9, which is the denominator for the 7/9, and the 12, which is the denominator for the 5/12. And what we do here is we actually factor these to their prime numbers, and that simply means a number times a number. It's the lowest term you can get the numbers in. So these are composite numbers, so we factor them to their lowest form, in other words. So this is actually 4 times 3, which is 12, but a 4 can be factored to 2 times 2, which is 4, and then times the 3. That gives us the information we need in the sense of what are these small values. Now, what do they share? We're going to look at what they don't share in this box, okay? And that's going to tell us some information we need. They both share a 3, which is great, but the 12 is missing a 3, so we have to put the 3 here. Now they both have 2 3s in it. The 9 doesn't have any 2's, so this is where we're going to put our 4, or both the 2's, however we want to look at it. So 3 times 12, so you take the number in the box, multiply it by that number you started with. 3 times 12 is 36, and 4 times 9 is 36. So over here, let's look at what we do. The 9 needs to be increased by a factor of 4. Well, it's really a factor of 4 that looks like a 1, because we're making it into an increased fraction, but we're not changing its value. It may look like it, but if we reduced it, we'd factor the 4 out in the end. So 4 times 7 is 28. Hope that doesn't confuse you at the moment. You may have to watch this video a couple times. And 4 times 9 gave us that 36 target that we were looking for earlier. Now the 12s had to be increased by a factor of 3, so we make that look like a number 1, even so that we're increasing everything to the same amount. That 3 looks pretty sad, don't you think? I'm trying to learn to write with the mouse still. So on top we have 3 times 5, and of course it's a subtraction problem. So here's our 15, 3 times 5. And 3 times 12 is 36. Now the target was to get the lowest common denominator for both of them. So this is called the LCD, okay? And it's called the least common multiple when we're just looking at whole numbers. So here we have 28 subtract 15, and we end up with 13 things left out of 36 things. Now, the 28 is larger than a 15, so this is a positive end result. We're going to go into positive and negatives in the end. So if the number, we'll look at signs in video on chapter 6, and I'll give you, probably it'll end up being 2 videos also. So don't worry about that right now. You had 28 pieces of a 36-inch cake. You took 15 pieces out of that, and you ended up with 13. So that's our first example. This over here is really important to understand how to do. There are other ways to do it, and I find that if I show students, they have to have the exact same thing all the way across. This has 3 times 3, 2 times 2 in it now. This has 2 times 2 times 3 times 3. They become the same spot on the number line, that not each one of them, but they end up being on the same area with the same denominator on the bottom as a result of this. So that was our first example of subtraction. Now let's do a problem of addition. And I'll do another subtraction in a minute. So let's do 1/4 added to 3/7 added to 3/14. Again, we have to determine the LCD, lowest common denominator. Where would these numbers have the same denominator if we looked at them? So let's look at the 4 and factor that, and we know from the last one it's 2 times 2 makes up this composite number of 4. And these are its prime numbers. And then we look at 7. Well, 7 is a prime number, so the only thing it can be multiplied by is its 1 in itself. You don't need the 1, so please realize that I'm going to exit out so that you don't get confused. We don't need the 1, because anything times 1 is that thing. Okay? And then the last number is this 14. Well, we know that 14 is composed of 2 times 7. 2 is the lowest prime number, okay? So now we have found all the necessary components that we need to determine where they need to be changed to be the same. This one has a 2. This doesn't have any 2's, but this has 2, the largest value. This one has its 2's. This one needs 2 of them, so I'm going to put 2 times 2. That made this one have the same value as this. This one has 1 2, see that? So it needs another 2. So we're going to put a 2 here. Now, this one has a 7, this one has a 7, this is missing a 7. So everything has 2 values of 2 and 1 7. So 7 times 4 is 28, see that? 7 times 4 equals 28. And then if I look at the 4 times 7, that equals 28. And then if I look at twice 14, I also get my 28. That's our target, okay? So we come over here and we take the numbers that we developed in the box and use them to create our common denominator between all of these fractions. And when we increase the bottom of something, we also have to increase the top by the same value. And that same value is different for each one of these. In the case of the 14, we had to double everything. So we're going to double the bottom and double the top. Maybe that'll make more sense than the last one. 2 times 3 is 6. And these are equivalent fractions. That's what our goal is. 2 times 14 is 28. When we keep equivalency, it helps us to understand that we're coming to the same spot. We're just increasing these values right here, but it's still the same number, but in an increased form. The next thing we do is look at our box. We have 4 here. 2 times 2 is 4. So everybody in here has to be quadded, or 4 times to you. Okay, so here we go. 4 times 7 is 28. And 4 times 3 is 12. Okay, and then here we had a factor of 7, so everything has to be increased by 7. 7 times 4 is 28. And 7 times 1 is 7. Now we just add, we keep the denominator because we're adding how many pieces are in this if it was only one element. We're adding them, summing them. So we're going to add 12 and 6, which is 18. And then we're going to add the 7 to it, which will create 25. Okay? Now, again, we can't reduce this number because 25 is composed of 5s. If we factored this, here's the 25. I'm going to move it over here so that I don't confuse you. 25 28ths. 5 times 5 is on the top. And on the bottom we have 4 times 7. Nothing in common, so we can't reduce it. Okay? So that is its finished form because of that reason. There's no reduction needed here. Our next step is going to be looking at another subtraction problem. And in this case, the subtraction problem let's look at one we have to borrow in, because this is usually the thing that upsets students the most, because they don't understand how to borrow for a subtraction problem. Not all students. Some students get it right away, but it's one of my experiences that I should go over this for your sake so that you have an idea of how to manipulate the numbers to your advantage so that you understand. The more insight you have when you leave this course, the better off you are for the next course. Now, the first thing is we have to find those common denominators. Well, 7 is part of a 14. It's twice 7. So I know right away, and it'll take a little effort on your part, but this one has to be increased by a value doubled in order to be in 14th so that we can work with them. So our bottom number just remains the same, and you just rewrite this piece of it, the 13 and 13 14ths, the same way. This one's going to change to 18 things, and then 2 times 7 is 14, and 2 times 6 is 12. Now 12 is smaller than 13, so I have to borrow from that 18. So in order to borrow, I'm taking out 1, so that leaves 17 things. Now, of course, our bottom just stays the same, so let's line all that up so that you can see that this stays the same. Now, when I borrow, I'm going to give you the detailed information, but then I'm going to give you the shortcut. I'm going to have 14 things, but a whole number over itself, in this case we have 14 things over 14 things, always equals 1. I'm borrowing 1 in this form because the denominator dictates what I have to borrow it in. Well, I already have 12 of these items, right? No longer equals that. This is what the 1 looked like. We also have 12, so we have 26 total for the top. Now the trick, or the shortcut to you, if I borrow 1 with 14 elements in it and I add it to how many I have up here, I will have 14 and 12 make 26. That is a shortcut to add these two together. Keep the denominator what it is, add the denominator to the numerator, write it on the top of the new fraction when you borrow, and it becomes my new numerator. Remember, I've taken out the 1, and it's a 14. Remember? 14 things out of 14, but the shortcut is just add these two together, take out 1, and then we have our new fraction. Now, if we subtract, we simply end up with 26 minus 13, which is 13, isn't it? 13 out of 14, because 13 and 13 is 26. And then we have 7 minus 3, which is 4. Again, this is a prime factor, and you can't reduce this because this is prime, and this is 2 times 7, so this problem is basically done. The important part of this whole problem is, do you know how to borrow? And here's the key. That 1, this was the 1, plus the number that was already represented as pieces. We've taken and cut a 1 into 14 things out of 14 things. That's our pie. You know, a piece of pie cut into 14 pieces. Kind of ridiculous. They'd be mushy, wouldn't they? But we also have 12 that we had left over from a different pie, so we sum these together to create this new form of the number. So that's the part that is tricky, and you'll get it. I'm confident you will. Okay, the next thing we're going to look at is a combination problem. A combination problem means simply that we're looking at addition, or in this case, we're going to look at division of fractions together. And I didn't do this in the last video because of time restraints, but this is somewhat of an order of operations problem, but it's really not. okay, 8/3, and then times 1/4. Okay, we learned in fraction when we did this in the first video that we don't do division. So this is my key point. I have to change that first. And we learned that the 2/9 would be multiplied by the inverse products of this number. In other words, we're going to flip this thing over. Okay, so now we have 3 things out of 8 things times 1 out of 4. The next step then is reduce out those elements, the prime factor elements that you see. Well, 2 can fit into 8 4 times. I can reduce those, or I could have used 2 and 4 twice. It doesn't matter. It's however you want to look at it. And then the next thing is to reduce. I see the 3 can fit in the 9, so I'm going to reduce. 3 fits here once, and 3 fits into 9 3 times. So I'm all done on top because 1 times 1 is 1 times 1 is 1. There's nothing else I can reduce out of this problem. So my next step is to say 3 times 4 is 12 times 4 is 48. I know this is in its lowest terms. I could have went 4 times 4 is 16 times 3 is 48. It's however you want to do it, because no matter what we multiply, it would come out no matter which direction. If we go this way or if we multiply this way, they're the same number. So those are just a few examples of what to look at in chapter 3. And this is usually the subtraction and the addition is usually what bothers students the most. I hope this was helpful. It has been to me. I enjoy doing these for you, and I hope that it adds to your repertoire. Good luck with it. I'll try to do it. I will have more videos for class in a while. Thank you. Have a great day.